Hello, we are ready to start Unit 3, which, as you might have guessed by the first word on this slide, is all about fractions. Let's review some key concepts. A fraction is a number that names part of a whole or part of a group. And the number on the top of the fraction is called you can say it with me if you know it, numerator. Make sure you write that down into your notes. And this number above the bar in the fraction, the numerator, that tells how many parts of the whole group are being considered. The number in the bottom of the fraction is called say it with me if you know it, denominator. Let me just get my red marker here. Oh, there we go. The denominator. Practice saying that 3 times. Denominator, denominator, denominator. And that's the number below the bar in the fraction, the denominator, that tells how many equal parts are in the whole or the group. So for instance, if I had the fraction 3/4, right, I know my numerator is a 3 and my denominator is a 4. That means I'm considering 3 out of 4 equal pieces. Another way to remember this is I think denominator down, and it's kind of catchy to say. Denominator down, denominator down, denominator down. And that way I remember the location of the denominator. Now let's practice with these images here. Hopefully you can see this pretty well. This fraction is showing visual representation in circles, and we want to know what part of the whole is shaded in number 1. Can you guess it? 1/2, or 1 out of the 2 equal pieces. And actually what I love about fractions is this fraction bar can be read a few different ways. We could say 1/2, that's probably the most common way you'll hear this read. You could say 1 out of 2. You could even say 1 divided by 2, because the fraction bar also it stands for division, right? We're dividing into equal parts, and that's just what the division symbol here is. So 1 divided by 2, you could even read it like that, and that's correct. Okay, let's look at this second one. What fraction would you use to represent the shaded region there? You are probably thinking 3/4. And the most common way to read that is 3/4. You might also say 3 out of 4, or you might say 3 divided by 4. And let's think, when are times when you might need to divide or share equally? Can you think of some times in your day-to-day life when that might happen? Perhaps you're thinking of when you have a certain amount of food, like a certain number of, or certain Halloween's coming up. Let's say you have certain number of pieces of candy and you want to share them equally with your friends. That might be a time. Or maybe you're thinking of when you're reading a book and you know you have a certain amount of pages and you have a week to finish it. So you want to split it up to read an equal amount each day. How much would you need to read each day? So we use fractions a lot in our day-to-day life, and we will practice with them in some number stories today. So here's this first problem. 2 brothers go to lunch and share 3 pizzas. How much pizza does each brother get? Be prepared to share a drawing you could use to solve the problem. So we need to read to understand what's the question really asking here. How much pizza does each brother get? So your answer is going to be in slices of pizza. I should maybe say how many slices of pizza might be better. You know those are going to be your units when you finally answer. I want you to pause this video and try this on your own. Also think about a drawing you could do to show this. And when you're done solving, play the video back and we will go over a couple different ways to solve this problem. Okay, so now I still want you to write this down in your notes, but we're going to go over two possible ways, and you can see if they match up with what your solution was. So the first strategy would be to think, can each group get one whole? How much is left over? And then divide the leftover object into the number of groups that need to be split. Let me show you what I mean by that. So we had 3 pizzas, but only 2 brothers. So if we ask ourselves, is there enough that each group could get one whole? In this case, we have 3 pizzas and 2 brothers. Could each get one whole? Yeah, absolutely. They could each get one entire pizza. Their lucky day. I hope they're hungry, right? So they could each get one whole. And now we're going to look at the leftover. So the leftover is this third pizza. And we're going to split that into the number of groups that it needs to be split into. In this case, we have 2 groups, or 2 brothers, so not really groups, but 2, we need to split it 2 ways. So split that in half, and then each of them can get one more half, right? So you would get 1.5 pizzas, or I guess so I had said slices of pizza, that was wrong. We're thinking of the pizza as the whole. So this should be 1.5 pizzas. Good. Another way you might solve this is by dividing each object into the number of groups it needs to be split into right from the get-go. So if I have 3 pizzas and 2 brothers, this time, instead of considering if each could get a whole, I'm just going to right away take these pizzas, and I know there are only 2 brothers, so I'm going to right away split each pizza into 2, into halves. And then I'll color code this maybe so it makes a little more sense. I'm going to say brother 1, he'll be orange. He's going to get a half, a half, and a half. And then brother 2, he'll be pink. He's going to get a half, and a half, right? So when we think about what brother 1 got, he got 3 halves. Same with brother 2. He got 3 halves. So you could also write 3 halves pizzas. But the cool thing is we know we were answering the same question, and so we know these 2 fractions right here, well, this one we actually will call a mixed number. You'll hear that term a lot later on. We'll start talking about that. A mixed number because it has part whole number, part fraction. This is the same as 3 halves. These are the same, or another, you know how I love math vocabulary. The mathematical way to say that would be that these are equivalent. And you hear that word equal in the adjective equivalent. These are equivalent amounts. Even though it's represented a slightly different way, they're equivalent amounts. In this case down here, we chose a numerator bigger than the denominator, so we would call that a fraction greater than 1. In fact, it's 1.5. Okay, but the main thing to remember is when solving 2 ways, you'll want to think, is there enough that each group could get one whole? And then you could split up the leftovers, or you could right off the bat divide the object into the number of groups that need to be split. So keep those strategies in mind as you are solving problems today. Have fun splitting some fractions.